Hello and welcome. We're going to go over this problem today. Final implementation of the minimum required characters. So let's get started. So the problem statement is the minimum characters required. We want to find the minimum characters required to make a string palindromic. So you're given a string. The only operation allowed is to insert characters in the beginning of the string. Return the number of characters that are needed to be inserted to make the string a palindrome string. No, you only need to implement the given function. Do not read input. Instead, use the arguments to the function. Do not print the output instead of return values as specified. So let's take a look at an example of what this is asking. So if you have an input ABC, then you want to make this a palindromic substring or a palindromic string, you have to add CB to the beginning of this string. So you have CBABC, and that would be a palindrome. And so that requires two operations, adding B and C to the front, or CB to the front. And so our output is going to be 2. And then for this example, AACE, CA, AAA, to make this a palindrome, we have to add AA to the front. So as you see, if you add AA to the front, then you get AA, AACE, CAAAA, which is the same backwards and forwards. And so you get a palindrome that way if you add the two AAs to the front, so, or the uh, two characters. So the output is 2. So similar for these examples. So for example, example 3, DDFG, FDDD. If you add D to the front, then you get a palindrome. And for DEFG, if you add GFE to the front, then you get a palindrome. So it's the required number of elements to add are 3 in the fourth case and 1 in the third case. And so this is basically what we're looking for when we're talking about how to um, find the minimum characters required to make a palindromic substring or a palindrome string. So let's get an understanding of what we're looking for. So yeah, but so we have a basic understanding, but let's just write it down. So our input is a string, and then our output is going to be um, the number of characters required to make required uh, number of characters required to be inserted to make a palindrome string. Okay, so let's continue on. So let's match this problem. So this problem is matchable to, say, for example, other similar uh, palindrome problems, and substring manipulation. Okay, so now let's plan for this problem. So what we're going to be doing is we're going to first write a is palindrome function. So verifies if palindrome. Then we're going to write a main character function, which takes the back string, so the back of the string, which is um like a slice of length s minus some counter. So that gives us like counter number uh, of elements from the back of the string. And appends it to the front of S. So we have new string equals backstring. So we want to take the reverse of this backstring actually and append it to the front of S. Appends the reverse. And then we want to call if palindrome on new string and return counter if is palindrome. Okay, and then at the end of while loop increments counter by 1. Okay, now we have an understanding of this problem or a plan of this problem we can implement. Okay, so we're going to write some functions up here. So definition is palindrome S, return S equals S negative 1. So it's a palindrome function. And main character is counter equals 1, while true backstring equals S with S minus counter. And then new string equals backstring 1 is S, and then F is palindrome S times counter, return counter. Let's say, yeah. And so at the final implementation of this get min required character, we're just going to call main character input string. Okay, so that should do it. So we get 6 out of 6. So this is an implementation of this problem. So let's look at the review of this problem. So this is we're going to step through this function. So we're going to print this get min required character function for ABCD, and so we want to define get min required character. We want to return main character S, and main character S is, we said, counter equals to 1, and while true, we take the back of the string and we add that to the front of the string, and we check to see if it's a palindrome. If it's not, um, then we go back and we take the back of the string plus 2 characters, and then we put that to the front of the string, the reverse of the characters, and we check to see if it's palindrome. And if it's not, then we continue on. Then we take back 3 characters of the string, or the back 3 characters of the string, yeah, and then we put that to the front, the reverse of that, and then we check to see if it's palindrome, and so it is, and so we exit and we get 3 as our number. Okay, so now that we have a review of this problem, then let's go about and evaluate this problem. So the evaluation of this problem is, I think it's ON. So we just, so evaluating palindrome is ON, and evaluating this main character O. So we have O(n) in this main character. So this main character is so the maximum, so it's n times n, so it's O(n) squared. So since his palindrome is sitting inside of this while loop, and this while loop is at least um, at most iterates at most n minus one times. So, or not n minus, should I say n minus one time. So um, it's going to be n times n, so it's n squared. And the time complexity. And it's O(n). I think it's O(n). And then it's also, so this, it requires O(n) space, and this is palindrome function. When we reverse the string, it takes O(n) space, and when we add on the back string, it takes most n minus one's strings, where n is the length of the string. So we're going to say, or at most. So we're going to say it's O(n) space complexity. So that completes this review of this problem. So thanks for watching.